In this video, I will calculate derivatives of two examples using definition of derivative. And the first example will be f of x equals x squared. This is the formula that we have to use to calculate these derivatives. So basically we have to calculate using the limit process, as we can see right here. Now we have to find all the factors that we need to have to use this definition. So f of x we already have, and it's just x squared. So now we have to find f x plus h. Okay. So if f of x is x squared, f of x plus h will be just x plus h squared. So now let's plug in everything into this formula. So we will have to write derivative equals limit with h to 0 and plug in every factor that we calculated earlier. So f of x plus h will be x plus h squared minus f of x squared. And we will divide by h as in the formula. Okay, so we have to simplify it now. It will equal x squared plus 2hx plus h squared minus x squared divided by h. And we have to remember to put the limit before this equation. So I will correct this n to 0. And now this h to 0. Okay, so x squared and negative x squared will add up to 0. And this leaves us with these two factors, and as we can see, both of them can be divided by h, so it leaves us with limit n to h to 0, and we have 2x plus h. H is 0, so it leaves us with 2x. And this is our answer. So derivative of x equals 2x. Now I'm gonna solve the second example, which is sine x. And we are looking for derivative of sine x. So we are following the same formula. So limit h to 0. And now we will be changing the x for x plus h, the same as in previous example, the same principle, minus sine x. And we are dividing by h. Okay, so this is n to 0, and it will be, and now we will have to use another principle that I have prepared here. And so we have this formula, and we can use it to calculate the sine with more than one number, and it will help us to calculate the limit. So we will have sine x cosine h plus sine h cosine x and minus sinus sine x. I will expand this and divide it by h. And now we have to simplify the equation. We can, for example, take out the sine from this part and this part. And now we will have sine x and the bracket cosine h minus 1 and minus sine h cosine x, and this is not minus but plus. Okay, and I purposely split it into two parts because now we can calculate the limit of two equations separately. So now we have sine x limit n to 0, h to 0, cosine h minus 1 divided by h plus cosine x limit h to 0 sine h divided by h. So from the formulas, for example, that sinus x limit x to 0 sinus x divided by x, it's 1, and this one right here will be 0 because cosine n or x or another variable will always be 1. So we have 1 minus 1, so we have 0. So this part will be 0 and this part will be 1. We can actually write it. This one will be 1 and this one will be 0. So we will have sine x multiply by 0, so we don't have sine x, plus cosine x multiply by 1. So the final answer is just cosine x. And we know that also from the table with formulas, so we can easily check if this is the right answer.